Now let's go to question 22. This one is asking us for an intersection. And even if it didn't specifically say intersection, we know we have two functions and we have a discussion of the answers. So that's an intersection. And for intersections, you want to get both of your equations in the y equals format and set them equal. So let's start by doing that. 2x squared minus 21x plus 64 equals 3x plus a. Now here we have a quadratic situation, and the instinct needs to be to get everything on one side equal to 0, preferably with the x squared term being positive. So for us, that means taking away 3x and taking away a from both sides. So 2x squared minus 24x plus 64 minus a equals 0. So right now, if a quadratic is in the format of ax squared plus bx plus c as more of like a standard equation, then for us, our a equals 2, our b is negative 24, and our c is surprisingly 64 minus a. C is everything that doesn't have an x attached to it. Now, the reason we're organizing this so well is because this is a classic situation for us to use the discriminant. Now, if you don't have the quadratic formula already memorized, you definitely must. But this is the application of that talks about how the number under the radical determines how many answers you'll have. If you have a positive under the radical, you'll have two solutions because you'd be adding and subtracting. A 0 under the radical, you'd have one solution because you wouldn't be adding or subtracting. Here, the answer would just be 2/3 in this sample. And if you had a negative under the radical, you'd have no solutions because you're not allowed to have a negative under a radical. So coming over here, we need to go ahead and set the discriminant equal to 0 because we're being told that there's one solution. So b squared minus 4ac has to equal 0. And we already know what our a, b, and c are. So let's go ahead and start using that. So b squared, negative 24 squared, minus 4 times 2 times 64 minus a equals 0. Now, once again, we're setting it equal to 0 because in this situation right here, if the discriminant were 0, that would result in one solution. So when they tell us in this question that there is one solution, this happens at one point, that's our hint that this whole thing, b squared minus 4ac, the part under the radical, should equal 0. So now 24 squared is 576 minus 8, 64 minus a equals 0. 576 minus 512 plus 8a, so we're distributing here, equals 0. 64 plus 8a equals 0. Take away 64 from both sides. 8a is negative 64 and divide by 8, and you'd get negative 8. But be careful not to pick this answer right now, because that'll happen a lot on the SAT where you feel like you just got an answer, but it's actually not what they were asking us for. The question was asking us for the value of x. So that means that we can maybe go into here and say, well, if a is negative 8, then this was y equals 3x minus 8. And now we'll actually find the intersection now that we have an answer for a. So once again, for intersections, you set them equal. So let's go ahead and write it down here actually. 2x squared minus 21x plus 64 equals 3x minus 8. Get everything on one side equal to 0 because that's what you do for quadratics. Take away 3x, add 8. You have 2x squared minus 24x plus 72 equals 0. And there's a little trick here. Here we have a GCF, and it makes everything a ton easier to realize. You can divide both sides by 2. X squared minus 12x plus 36 equals 0. Now we're in a BC factoring situation. We have a BC quadratic. There's no number in the A spot of the quadratic. So it's BC factoring, which means we need two numbers that add to -12 and multiply to 36. What two numbers do that? X minus 6 and x minus 6. So we can write that as x minus 6 squared equals 0. Take the square root of both sides, and we'll get x minus 6 is 0. Add 6 to both sides, and you get x equals 6, which is answer choice C for this incredibly long question.